Again, welcome to lecture number 7. And in this lecture, we are going to cover the algebraic fractions. Again, that this is Mathematics 164 Pre-Calculus at New Jersey City University. So algebraic fractions, anytime we have a fraction, the fraction normally means a numerator divided by a denominator. So we know a fraction of, let's say, multiplication, addition, subtraction. So example they gave us here, fraction can be 6 by 8. 6 is our numerator, 8 is our denominator, or 3 by 4, which means we can reduce 6 by 8 to 3 by 4. Also, if I have s plus 2 times s plus 1 divided by s plus 1 times s plus 3, I can reduce it to s plus 2 divided by s plus 3, because s plus 1 can cancel each other here. So we get s plus 2 over s plus 3. So simplified fraction simply means we can either factorize the numerator, if possible, and so the denominator, and later we can divide by cancel the expressions or the values. So we start with the product of a fraction. So for example, here I have 4 by 5 times 10 by 12 times 2 by 5. If we like, we can multiply 4, 10, and 2. So we multiply everything at the numerator, and we do the same thing for the denominator. So we get 80 by 300. Then we can cancel, we can reduce it. Or I can see that 5 can go into 10 is 2, so I can cancel from beginning. And also 4 can go into 12 is 3, so I'll cancel 4, then we have 3 here, which means I have 3 times 5, and I have 2 times 2, so it will give me 415. So the same concept applied to dividing or fractions with algebra expressions such as polynomials or binomial, trinomial. So the second option, as I said, we can cancel before we multiply the rest. So with algebraic fractions, we can again do something like factoring, reducing the terms. That's when I mean reducing means we cancel the terms. For example, if I have 2 by 4, I would say 2 can go into 2, 1, 2 can go into 4 is 2. So instead of 2 by 4, I write half or 1 by 2. So let's see how this works. This is an example given to us, a squared b by c divided ab by c squared. Also we have b, we have 6 s squared minus 6 divided by s squared plus 3s plus 2, or divided by s minus 1, s squared plus 4s plus 4. So in this case, I can write the expression by means division. Then, as we all remember, in a fraction quotient, we change the quotient sign to multiplication or product. Then we turn the next fraction upside down. So this is the same as writing a squared b divided by c. Instead of division, we say multiplication. Then instead of ab divided by c squared, we say c squared divided by ab. Then from here, we can cancel. C can go into c squared, c. AB will cancel a squared b to remain with only a. So our answer will be AC. Now, the second question is more interesting because we can see that here we have binomial, trinomial divided by binomial and trinomial. First thing, of course, always we change the division sign to multiplication. Then I can look at the expression if I can factorize or reduce the fraction. Here I can see that there can be a factorize because 6 is common here. And here most likely I can do the trinomial factorize, which will be 2 times 1 is 2, 2 plus 1 is 3. So I'll get s plus 1 multiplied by s plus 2. Here I'll get 6 outside, s squared minus 1. S squared minus 1 is the difference of two squares. It will be s plus 1, s minus 1. The same thing apply here. Let's see if we can factorize this. Find two numbers. When you multiply, you get 4. When you combine, you get 4. Yeah, that's right. 2 times 2 is 4. 2 plus 2 is 4. So we can get s plus 2 and another s plus 2. So let's see how we write everything. So the first, we find a common factor out. So we get 6. S squared minus 1. But s squared minus 1 is the difference of two squares. So it's the same as writing s minus 1, s plus 1. The down, we set it to be s plus 2 and then s plus 1, because 2 times 1 is 2, 2 plus 1 is 3. And that's what we have here, s plus 2, s plus 1. So what we're doing first is factorizing. Then when we have product throughout, it's easier to cancel. So this is s plus 2, s plus 2, then we have s plus 1. So we can say that s plus 1 will cancel s plus 1, s minus 1 will cancel s minus 1. We have s plus 2 here, another s plus 2. So we're going to reduce it. And our final, so we can see s plus 2 cancel s plus 2. So left with 1 s plus 2. S plus 1 cancel s plus 1. S minus 1 cancel s plus 1. So left with only 6 and s plus 2. Adding a subtracting fraction, we know from our elementary arithmetic, we have to find the least common denominators for adding a subtraction. So if, for example, I have a question, here we have 1 over s squared minus x, comma, 1 over s squared minus 1, comma. So we have to find the least common denominator for all the 3 terms here, s squared x, s squared minus 1, and s squared. So first we factorize the first term, we get x times s minus 1. Second one is difference of two squares, so we get s plus 1 and s minus 1. And the last one will be s times x. Then we find the common, different factors, the common also. So let's see this example here. See, here we have plus, now it's not a quotient or product. So s minus 3 is lowest term already, s minus 5 the same. So we can find the factorization of s squared minus, no, sorry, y squared minus y minus 20. And that's what is written here. I can use 4 and 5 because I know the difference of 4 and 5 will give me 1. So they use 4 and 5. Minus 5, the reason why, because minus 5 plus 4 will give me minus 1. Minus 5 times 4 is minus 20, so that's perfect. So we will place it here. And we have y minus 4, y minus 3. We divide y plus 4, y plus 4. Then by simplifying, we get y squared plus y minus 12 plus y minus 3. Since the denominator is the same, we just combine the items here. So y minus y minus 5, y plus 4, y minus 5, y plus 2. Oh no, sorry, this is y plus 4, it should be 4. Yeah, it should be 4. So here we can simplify, get y squared plus 2y minus 35. Then we factorize it, find two values. When you multiply, you get 35. When you combine, you get 2, and that will be 7 and 5. Since it's negative and 2 is positive, then we give the lowest value negative sign, which is negative 5 and positive 7. So negative 5, positive 7 will give me positive 2, which is what I'm looking at. So from here, we can see that y minus 5 will cancel each other. And the final answer will be y plus 7 over y plus 3. Sometimes we have complex fraction, means maybe we have division by d. For example, here we have 1/3 plus 4 by x, all divided by 3 minus But again, when we have something like this, all we need to do is change this division sign to multiplication. Then combine the addition together using the SCD. The difference also the same thing. So this is an example given to us. Yeah, I can change s to the power negative 3 is the same as 1 over s to the power 3 plus s squared by y to the power negative 3 will be 1 over y to the power 3. So that's why we have y cubed here. Then this is negative 2, so it will be everything 1 over xy all square. Then here we look for the LCD. We said it's s cube y cube. Well, we are doing this, the top here. So y cube s cube divided by s cube, it will left with only y cube. And then multiply by 1, so we get y cube. The y cube, s cube, y cube left with s cube. Multiply by s squared, give me s to the power 5th. So that's what we are doing here. So we use the s cube, y cube for each term. And our final solution will be y cube plus s to the power 5. The reason why we get this, again, here we find the LCM. Then we combine this. The y cube, s cube, with this will cancel. Here, cube divided by square, so we left with s and y, so that is the s and y. We can also rationalize denominators. Rationalize denominators means we want to remove the radical sign. So if I have 1 over square root of s minus 2, and the goal is to move the radical sign. The same thing here also, we have square root of x and square root of 5. The main goal is to remove the radical signs. So the only way I can remove the radical sign here is maybe using difference of 2 square. So that square will cancel the square root. So here we say s minus 5 minus 2 by s plus 2. This will remove the x of this. And if I multiply square root of s minus 2 by square root of s plus 2, I have to do the same thing at the numerator. So that's why we get this square root of s plus 2 over square root of s. So difference of 2 square, we get s minus 4. And the top will be s plus. The square root can remain at the top, the numerator. The rationalized denominator means removing the square root from the denominator. So the second one also the same thing. Look for the, we have square root of s plus square root of 5. So we find the conjugate, and that gives us a difference of 2 squares. So it will cancel the square and square root cancel out. So we multiply everything at the top, and this is what we get. 3 times square root of s will give me 3 square root of x. 3 times negative square root of 5 will give me negative 3 square root of 5 plus square root of s times square root of s will be x. Then square root of s times negative square root of 5 will be negative square root of 5x. So in this session, we're going to learn simplifying rational expression, multiplying rational algebraic expression, also how to add rational algebraic expression, and also solving the rational equations. So we already know what is factors, so I'll skip that section. And we talk about the exponential rules already. A to the power n divided by a to the power n is the same as a n minus n. A to the power 0, anything raised to the power 0 is always 1. So if I have this question, I know negative 7 will go to 14, I will get negative 2. Since m4 is dividing m to the power 9, I'll have 4 minus 9. That will give me negative 5. If I want to make it positive, I will bring it down. So our answer will be negative 2 over m to the power fifth, or negative 2 times m to the power negative fifth. So here, the first thing we do, same as the previous example, is to factorize the top, which we get s minus 2, s minus 2. Because minus 2 multiply will give me positive 4. Minus 2 combined will give me negative 4. So this is correct. This is difference of 2, so I can see 2 squared minus s squared. So that will give me 2 minus s times 2 plus x. So from here, we can see that s minus 2, 2 minus s will cancel each other, but it will give us negative 1. So we can change the sign here to 2 minus x instead of s minus 2. So this is also another example. We can factorize individually. So here, common denominator 3x, 4s plus 1. The common value is 5. 5 can go into 10, 5 can go into 15, so 5, 2s minus 3. Then here we have 8 and 12, so 4 is good, 2s minus 3. 9 and 18, 9 is good, so s plus 2. Then we can see 2s minus 3 will cancel 2s minus 3. And 9 with 3s, 3 can go into 9 is 3, so it left here with 4x times 4s plus 1, everything over 3, 15, s plus 2. We have 5 here, 3, 15. So first thing we said, this is division, so we change it to multiplication. Then we find the difference of 2 squared, because 49 minus s squared is the same as 7 squared minus s squared. So it will give me 7 minus s times 7 plus x. And here we are going to see if we can factorize it. And I think it will work. 7 times 7, negative 7 times negative 7 is positive 49. Then combining negative 7 and negative 7 will give me negative 14. So this works. But since we are turning our division to multiplication, the top will come down. So s minus 7, s minus is down. Then we cancel 1 out. We can also cancel the s cube with the s raised to the power fifth. To left with only 2 down. We can also do y cube. So our final solution will be negative y cube 7 plus x divided by s squared, s minus 7. So here we have 4xy squared. Factors will be 4 is 2, x is x, y squared is y. And here we have 12xy squared plus 6y. The common factor will be 6y, and 12x y squared divided by 6y will give me 2sy. 6y divided by 6y will give me 1, so plus 1. And that will give me 2 and 3 for 6. We change it to prime factors. Here we get again 2s y 3, 2s y plus 1. We get 2y, and s cube. So here we find the SCD first. And we can see it's 3x, s plus 2. And that will give me x at the top, 3. Difference also is the same. So we factorize this. Two numbers, when you multiply, you get negative 8 will be positive 4 and negative 2. When you combine, you get positive 2. Then we have s plus 4. So we get 5s plus minus 2s plus 4. Because minus 2 times s minus 2. Then our final solution will be 3x plus 4 over x plus 4 and s minus 2. So we can also solve rational equations. Equation means we have an equal sign between the expression. Here the goal will be to find the value of x. So first I will look for the LCM. Then we solve the problem. So first 5 multiplied by s minus s plus 9. Then 2 with the s minus 5. So you get 5s minus 25 equal to 2s plus 18. I don't need the 2, so I'll take it to the left side. So I'll get 3s minus 25 equal to 18. I don't need the 25. I take it to the right side, so I'll get 3s equal to 43. I multiply 3s, so I divide by 3. I divide the other side, and I'll get 43 by 3. So again, thank you for this lecture. So this lecture we discuss about algebraic expression, simplify it, other addition, subtraction, multiplication, division. We saw that the same concept as fractions. Addition and subtraction, we have to find the LCM. Multiplication, we solve it straight. Division, we have to change it to multiplication. So the same concept here. But when it's an algebraic expression, our goal again is to work with the factors. I have polynomial or binomial, maybe I have to factorize it first before I can cancel. So we have to pay attention to that. So wish everybody the best again. Thank you.